So good morning, everybody. I, Harpreet Singh Gill, Associate Professor, Department of CSE at SKIT Jaipur, welcome you to the first session of Day 1 of Atal Academy sponsored online FDP on electrical and computer engineering, application of machine learning and AI. So this session is on the topic of introduction of applications and intelligence of deep learning. This topic will be presented by Dr. Santosh Kumar Viparthi, Assistant Professor at MNIT Jaipur. Over to you, sir.
Yeah, thank you, sir. Good morning, everyone. I hope my screen is visible to you guys.
Yes, sir, it's visible.
Yeah. So, as I said, myself is Dr. Santosh Kumar Viparthi, working as an assistant professor in the Department of Computer Science Engineering, MNIT Jaipur. I am leading this particular Vision Intelligence lab. So from there you can able to see the latest works. What are the things we are trying to do in MNIT itself. Today we're going to discuss about some of the applications and the challenges of deep learning in the field of deep learning. Before going to talk about the deep learning concepts, let's see why we need to go for a learning. You know that machine learning and artificial intelligence are very popular, and these, especially these days, AI has attracted most of the researchers in the field. It is irrespective of the domains of natural language processing or computer vision. It attracts in almost every field. What might be the reason? The first reason is availability of the infrastructure. Nowadays, current these days, the availability of the infrastructure is very cheaper as compared to the olden days. If you are ready to invest 1 lakh of 1 lakh, then we will going to get the GPU based machine. Either it can be a desktop or laptop or anything. So processing of a data is now easier, and availability of the data for few applications are also an easier task. That is the reason nowadays the artificial intelligence was got attracted, especially whenever the deep learning has started and a new type of a boom was formed due to the self-learning capabilities of a system. But before going to see this, what was this learning? Why we are trying to use this artificial intelligence? Because a human will have a natural intelligence, right? But whenever you're trying to imposing our natural intelligence to a machine, now it become an artificial intelligence. Now the task will come here is how you can able to make a machine to learn, or how we can able to make a machine to understand the situation. Depending upon an application or depending upon our end target, we would like to adopt some of the learning techniques, and based on those techniques, we can able to make a machine to follow our instructions based on our targets. Suppose if you would like to do a classification between the fruits, or do a classification between a gender, do a classification between the different size of an objects. If this is a task of a classification, then we can able to make a machine to understand what are the features of an input. Then based on the features and the properties, the features can be anything. So based on the features, we can able to further classify what type of a class the particular input is belongs to. So we can able to make a machine to understand. Let's assume, especially these days, because of the AI, now we are trying to do a predicting something. So before it going to happen, do we able to predict? Now these particular predicting technologies are going to attracting the most of the researchers in various fields. So we will see some of the things in today's presentation. So in this particular process of machine learning or artificial intelligence, I hope everyone will get aware of these concepts of supervised learning and unsupervised learning. What was the difference of a supervised learning and the deep learning? Because the supervised learning and the machine learning concepts are traditional approaches, and everyone will clearly aware of it. But from the last few 5 to 6 years, if you can able to see, the people are going to talk about the concept of deep learning. So what was the actual difference? Is this deep learning is completely a new concept, or it was just an extension of some existing concepts? What actually the technical differences? Let's see. Let's assume this is your case. Like here your objective is, just a second, sorry. Hello. I'm in a lecture. At 12 o'clock I'll talk. Okay. Anything urgent? या फाइन, मैं 12 बजे कर दूंगा, ठीक है, थैंक यू. Sorry. So now, if this is your target is whether this particular given input image is an indoor image and outdoor image, how we can able to do that? So first of all, we need to analyze what type of a feature particular input image is having. So that analyzing the features are called traditional or handcrafted features. That is called extracting handcrafted features. We would like to extract what type of an objects are there in a particular input image, or what type of the properties the input image is having. And we are well aware that indoor images are having different lighting conditions and the illumination conditions as compared to the outdoor objects or outdoor images, right? So based on the properties what the input image is having, first we need to extract the features. The once the features have extracted, then we are going to pass these features to one of the training classifier. Here the training classifier either it can be an SVM or it can be neural network or anything, or KNN, random forest or anything. So you are extracting the features from an input given image, and those features you are passing or feeding to a training classifier, and based on the features the classifier is training, then it is going to give an output. So here the challenging question here is what type of features we would like to extract. So this particular thing is a challenging task. So what type of features we would like to extract from an input given image based on the application is a challenging task. So that was a little tedious and costly affair. Now, one feature we have extracted, and that particular type of features may be applicable for one type of an application only. So this was an application dependent. That means a target specific researchers need to extract the relevant features from an input given image. But comes to a deep learning is something different. So instead of what type of features I need to extract, the network itself will going to learn what type of features are better for my input given image, or what type of features are better for a particular given application based on the input data sets or availability of the input data. What actually the difference of the machine learning and the deep learning concepts? So you can able to see it here in the deep learning concepts. Initially, we would like to extract the low-level features, mid-level features, high-level features, then the classifier, then output. So you can able to observe here the features and the classifier. These are all a single step. So you can able to see it here. These are all a single step. That means the features are going to learn based on the input properties rather than the classifier is learning in the machine learning strategies. So in the deep learning strategies, we would like to learn the what type of features are there. But is this called deep learning? No, not at all. Because input is there in the basic applications. If you can able to extract different features from input image in a sequential manner, then it can also be called as a deep learning. Or in other sense, you can consider that whenever we are going to use the neural network concepts, instead of using a single hidden layer, if you can able to use more hidden layer, then it can be also called as a deep learning. So the concept of deep learning is already existing in many years onwards. This is not a nothing new concept. But why was it so popular? Because in this particular concept of deep learning, there is a new technology or a new terminology came in between that is called CNN, convolutional neural network. Again, the concept of convolution is nothing new. It was also an old concept only, but the availability of the resources make this particular CNN or deep learning concepts a little popular. So this is how the particular deep learning will going to work. As I told you, if the deep learning input low-level feature, multi-level features, and training classifiers and output, let's take if it is an image. First of all, we would like to analyze the pixels. From there, you need to extract some of the edges, then textures and motifs, then object parts and objects. If it is a text processing or NLP concept, then initially we need to go for the characters, then words, word groups, clause, sentences, and further story. So depending upon what type of application we would like to use, based on that, thus we need to select what type of a deep learning algorithm we need to adopt. But so what was the important aspect nowadays? What are the machine learning algorithm you would like to apply, or what are the deep learning algorithm you would like to apply? We have a similar limitations are there. In the basic deep learning approaches or the basic deep neural network approaches, there are some small limitations were there. What was that limitations? Let's see. Now let's input data is here for easy understanding. We have given this input image as 16 cross 16. You can take any data. So the data, from the data, we need to extract the features. And those features we need to feed it to the neural network. That is called, we need to give input of we need to give these features as an input to the neural networks and the input layer. So to make you understand, here I have given input of 16 cross 16. Simply we have flattening the data. That is called 1 cross 256 features we are feeding to a neural network. And here I have only one hidden layer. Here we are going to use 100 hidden units just for simple easy multiplication process. 100 hidden units, and as here input is a character, so I would like to swear 26 digits. So it's a digit classification. So the output neurons will be 26 here. It's called A to Z. So with this, you can able to observe one thing, that there is an input 256, 1 cross 256. Hidden units are 100, and output neurons are 26. So which one will be dependent upon the application? Input, hidden layer, or output neurons? So with this, we can able to analyze that the output neurons are depending upon what type of an application we would like to solve. So here, if you want to go for the digit classification, here you have 10 digits. If you're going for a character classification, you have 26 characters. If you're going for the cat and dog classification, here output neurons are 2. If you go for a gender classification, you will have a 2 or 3. So depending upon what type of an application you end, the output neurons are going to be changed. What about the input neurons? The input neurons are depending upon the size of the image, or depending upon what type of features you would like to extract. Based on the features you would like to extract, the input neurons are dependent. What about the hidden units? Hidden units are an application dependent. Here you can go for the 100 units, or it can go for 1,000 units, or you can go for 1,000,000 units. So how many number of units we need to select? Again, that will be our target. What was our target? Minimum number of parameters. So how we can able to decide this parameter calculation? Let's see here. As I told you, here I have input neurons are 256. Hidden units are 100. Output neurons are 26. You knew that neural network concepts are fully connected neural network. FCNN. You knew that it is a fully connected neural network. What is the definition? Every input neuron is connected to the every hidden unit. Here, every input neuron is connected to the every hidden unit. So, how many number of connections are happen in between this input and the hidden units? So 256 inputs are there. Every input neuron is connected to every hidden units. How many hidden units is there? 100. So 256, 100. 100 hidden units, we are adding biases 100. And at this level, the left side, the input is input neurons. With respect to this output neurons, from where you will get the inputs, the response of the hidden unit responses are considering as treating as an input to the output layer. So here, how many hidden units are there? 100 hidden units are there. 100. How many output neurons are there? 26. So 2600, 26 biases, output neurons. So total in this small example, you have 8,326 parameters are involved in this particular example. Okay, fine. Now, is it what was the limitation out of it? Fine, 28,000 was there. It's a limited number, but then what will be the limitation? Let's focus on this particular problem of basic neural network concept, because the concept of neural networks is very common. You knew already. You see the limitations here. Let's treat this example here. With the same example, we are going to flattening the data in this manner. Every pixel we are flattening, and the last pixel represented here. Let's try to focus on this small area. Here in this area, you can able to see here. Here in this area, you can able to see there are 2 green dots and 2 red dots. The green dots are representing the white patches, and the red dots are representing the black patches. It's nothing but green dots are representing the background, and the black dots are representing a foreground. Now, let's represent, as it is a binary representation, zeros and ones, let's represent this particular form in a form of a binary. So let's represent this in a representation at this particular level. The white patch is nothing but 1 1, black is representing with a 0 0. At this particular pixel, the neural networks, here I am passing input neurons as 1100. So based on the properties, I will going to get some non-zero value. Let's assume your input data is little shifted. Let's assume your input data is little shifted. Let's assume your input data is little shifted towards the left side, that is got translated. The data is little translated towards the left side. At the same location, you can observe here, in place of green dots, in the previous thing, it is a white patches. But now as the input is little shifted towards the left side, at the same location, you are getting the black spots. So the black is represented with 0, 0. So though previously at the same location, you are passing 1100 as an input, but because of the input translation, here you are passing 0, 0 and 0, 0. So here the resultant of the neural networks will become 0 here. So with this, you can able to see this particular concept of neural networks are little sensitive to translational, rotation, and scale variance. Because if the input changes, the output also going to be changed. These things which misleads to a distortion in the output. So you can able to get this type of distortion output. So this was the one basic limitation of a standard neural network concept. But how in the literature before deep learning concepts, how the researchers have solved this particular problem? That is how in the traditional approach or in the basic before deep learning concepts, if you might be seen, the researchers have extracted rotational or scale invariant features. You might be seen this. There are scale invariant features they would like to extract. Even the objects are rotated, even though the scale has changed, but for a particular object, your algorithm has to extract the features properly. So they used to extract the rotational scale invariant features from an input given data, and those features they used to feed it to the neural network so that it can able to handle this rotational scale invariant problems. Otherwise, the basic concepts of neural networks are also going to be little sensitive to this scale invariant and rotational shifts or rotational variations. Now let's see. Are you able to follow me?
Yes, sir.
Okay. If you feel I'm going a little faster, please, interrupt me so that we can have a discussion. Now let's see the second case. In some of the applications, you might be seeing two different type of the same application. You might be seeing two different type of solutions in the traditional approaches. What was that? Let's assume the case. This is one application, simple classification problem. Here in this case, we are going to go for the 6th class expression or a 7th class expression. 6th class problem or 7th class problem for easy understanding, you can able to say. So whenever we would like to apply any of the classification problem, we need a data set. So we have one data set here, one data set. So whenever we are going to apply any of the machine learning or any algorithm, we need to divide this data into two parts. That is called training set and testing set. Let's assume the data division strategy of this particular data set is same. You have divided the same one strategy, the 6th class problem as well as 7th class problem. You have now you have applied a different feature extractors with the same classifier. Here let's assume the classifier is a SVM or a neural network. These are all the results for the SVM. You can test it for the neural network also, that is not a big deal. But if you can able to see it here, you can able to see it here different recognition analysis. Why so it's happening? The data set is same, data division strategy is also same, and type of a classifier you would like to use is also a same throughout this application. But if I'm going to change the method, the accuracy is going to be changed. What this method is going to represent? Here the method is representing a feature extractor, that is called feature descriptor. How you can able to describe features from for a input given image for this particular application. the way you are going to analyze or extracting the features from a given input image, and which leads to a better classification accuracy. That means your classifier is easily able to classify the things, because input features are so robust enough so that the classifier is easily able to classify. So now you are not depending upon what type of a classifier you would like to use it. You, in this case, you are depending upon what type of a feature extractor you need to develop. So this is how you can able to define that what was your end goal. So your end goal is to extract a robust recognition accuracy. That means when you are developing an algorithm which should recognize properly. So for that, either you can freeze one of the classifier and you can change the feature extractor, you will going to get the output. But recently, some of the articles you can able to observe, they are taking a same feature extractor and they're changing the various classifiers, and they're saying this classifier is giving a better performance. This strategy is also one type of a correct strategy, but the limitation here is, what was your end goal? Is your end goal is to analyze what type of a classifier is doing the proper classification? Is this your target? Or what is a better way to extract the features is your target? So based on target, you need to select. So this is the thing we need to observe. So here in this particular case, the feature extractors are going to play a very important role. Coming to this particular deep learning or machine learning algorithms, what was the applications or where these particular concepts are going to be used widely? The first one is image retrieval. The easy understanding of your image retrieval is your Google Lens. Most of your smartphones might be having this Google Lens. So I hope you might be already analyzed the concepts of Google, right? Whenever you're going to open a Google Lens and open a lens in front of any of the object, if your mobile is connected to internet, it can able to analyze it can able to show you the outputs as a relevant links. So if you're giving then what's happening inside? The Google Lens are trying to capture a image, and it will going to analyzing the properties of that particular image, input given image. Based on the properties, it is going to give you the relevant links or relevant information. That means it is trying to retrieve the relevant information from the database, Google database. That is called Google Lens is doing. This is how one application of image retrieval. You might be seen in your Google search, there is an option called search through an image. You might be already seen, right? So search through an image. Instead of searching to a text, you can able to load an input image as a query. It will going to give you the relevant responses. So that is another importance of the Google Lens retrieval problem. And this particular retrieval is having many number of applications. It is just a you can able to see this image retrieval concept is an interdisciplinary problem for many of the sub applications. So based on your requirements, you can able to do that. Some of the problems we will going to discuss. Another one is mission translations. This is nowadays it will be very useful applications. Mission translations. Whenever you will going to travel to an abroad, this mission translation is going to help us. So what this particular mission translation is going to do? It is not only the language translator. In this particular image, you can able to see this. The menu is translated from one language to another language. So what are the things that are happening here? You can able to observe here. There are two different technologies are going to use. One is one is computer vision, another one is a natural language processing. So first you are trying to capture an image with the help of OCR, object character recognition concept. You are going to recognizing the characters, then converting these characters from one language to another language with the help of natural language processing. So here image processing and text processing both are involved in this particular problem, that is called mission translation problem. But of course, yes, it is also having very number of limitations. Whenever you are going to use on the handwritten characters, then some of the algorithms will going to fail. So we need to develop a robust algorithm on this. Very challenging and a very interesting problem. There is the object detection and classification. This is called object recognition. So nowadays, everyone is talking about autonomous cars, right? The autonomous car needs to recognize what the object is. Here, the object, the autonomous vehicle no need to be recognize name of the person, but definitely it has to recognize whether the input given object is a person or an animal or a vehicle and so on. So how it can able to recognize? Again, here the discussion will going to happen is the object recognitions. So object recognition, whenever I'm talking about an object recognition, it will going to be recognized as static objects as well, because you can able to see in this particular clip, on the in the background there is a truck, bigger truck, which is a static, it is loading, and another truck is moving. So this algorithm is going to be recognizing static as well as the moving objects. So this is one type of an application. There is another application only for detecting moving objects. And this is another problem is image segmentation problem. So as I already told you, this autonomous vehicle, this is another interesting problem. It will going to be segmenting the people, vehicles, trees into different segments, so that it can able to take a decision nicely. So how we can able to do this? And this particular image segmentation problem also having many wide variety of applications. Few applications we will going to discuss. This having many wide variety of applications, and of course it will going to have some limitations as well. We'll see some of those limitations on to few applications. Now you're able to see as I shown you that the image segmentation problem here. This is called change detection. Change detection is nothing but moving object detection. Wherever the changes are there, just you need to detect those things. And which is not moving, you don't need to be detect, as I told you, right? So whenever the term you can able to see here, the change detection or moving object detection. So what is moving? Only those things need to be detected. So how you can able to analyze something which is moving? To do that, we need to consider the temporal information. That is you need to analyze something with respect to a time. So you can able to see in this particular diagram here, that the left side two things and the right side two things, you can able to see it here. What was the difference here? These two things, the moving objects are detected. You can clearly observe here in the both the clips, the moving objects are detected. But what was the difference between these two? The difference between these two was, the first one is bounding box based moving object detection, and second one is binary segmentation based moving object detection or a change detection. So you can able to analyze in these cases. The second case is a segmentation problem. So here in this case we are considering the binary segmentation problem. So we are considering foreground as here we are considering only two things. One is a foreground, another one is a background. You can able to clearly see on the right side. You can able to see it here, right side. So here binary segmentation concept we have adopted to solve a particular problem. But in this case, the label based concepts are adopted here. Why it will be useful, what are the limitations? We will see that those limitations and challenges later on. So a particular problem can be solved in two different ways. One is the bounding box based, another one is segmentation based problems. Similarly, the problems of deep learning can be further extended to many other applications. The first one is intrusion detection. You can able to see it here. Intrusion detection is one application. So you can able to analyze what is one by an intrusion. The definition of intrusion is going to play a very important role. So we will discuss further in details about this intrusion and all after some time. Now you can able to see this traffic monitoring. So traffic monitoring is one another application, and you can able to see it here. These are the two vehicles which are violating. Some of the vehicles are trying to violating the rules. So those things also we can able to easily able to observe. In the traffic monitoring, you can able to see you can analyze in such a way. You knew that how a basic normal condition of a traffic, and you knew that how many lines of a road you are going to use it at the particular location. Once the background is ready, then we can able to analyze how many number of vehicles are there, or what type of a traffic scenarios at what time, what type of a traffic is there. We can easily able to analyze through vision processing applications. And the intrusion detection in the night views, we will see this later. And this is one another interesting problem is the violence detection. Violence is also one type of an anomaly or abnormal activity, right? It was not a normal activity, it was an abnormal activity. But here, if you can able to see a little interesting problem on the right side, here a particular person is trying to aiming on a shopkeeper. Here the person is trying to aim a gun towards a shopkeeper. So aiming a gun, this particular action is not a normal action because here the object is a gun. We might be showing a finger, that is not an anomalous activity. But whenever it is going to show an object as a gun towards a particular person, then it might be a violent activity or it is an abnormal activity. So whenever we are going to defining this condition of an abnormality on a normal shop, it is little easier as compared to a shop which is already having the collection of guns and collection of guns. So how you can analyze? I hope you are able to differentiate the difference between these two things, right? This particular example, here the shop was a normal shop. So that whenever the shop is a normal shop, whenever you can able to find out a gun object, you can able to see this. Yes, this is a anomalous activity. So gun is a first anomalous event, anomalous object or violent object. So the action the particular person is trying to show is definitely an anomalous activity. But let's assume the second case. The second challenging is, assume your shop itself is a gun shop. Then, hello, madam. Happy New Year, madam. Lecture के बाद मिलते हैं. So let's assume you are in a gun shop and you are going to sell the guns. So then what you're going to do? There any particular person can come and they can able to see the guns and they can able to show the gun towards a particular shopkeeper. Now, as the shop itself is a gun shop, showing a gun towards a shopkeeper is not an abnormal activity, it was a normal activity. Now, how you can able to take a decision? Then you have to go for the high level processing depending upon the what type of an action a particular person is trying to do. So defining something which is a violence or whether it is a normal activity, we need to define on which particular application and what are all the normal conditions we are going to consider this. What type of an activity we are considering as an abnormality or a violence, based on that the resultant responses are going to be changed. So this is another application where we need to, it will be more little challenging to solve a particular problem. Now, intelligent monitoring at industrial sites, leakage detection. You might be seen from in 2 months back during the lockdown in Visakhapatnam, Andhra Pradesh, there is a huge leakage from a chemical factory. If a particular algorithm is going to detect in the early stage itself, we can able to take an alerting. We can alert the secure systems or whatever the systems we can alert. So the leakage detection is also attracted most of the researchers. And anomaly detection, we'll discuss this anomalies after some time. Another one is detection based tracking. So detection based tracking, this is another way of analyzing the trajectory movements of a particular object. We can easily able to analyze a trajectory. So how we can able to analyze? Because here we can able to analyze the behavior of a particular player, how a player is going to play or how a player is going to behave in a playground. We can able to do that because of, due to this tracking of a particular activity of a person and the posture. So this is another application. Another one is forensic analysis. This is very, very important aspect and very challenging aspect also. Everywhere the availability of the CC cameras are there. Everywhere CC cameras are there. Now, all the CC cameras are used for the post forensic purpose only. Most of the cameras are used for the post forensic purpose. Either it can be bank, whether it can be schools, whether it can be ATMs or anything. Once something some event was happened, then only we are going to analyzing in the available video streams what actually was happened and when it is happened, how they have planned. So if we can able to develop a system, then this alerting system also can be done, or the post forensic process also can be minimized. So there are many secure applications are there. Maybe further analysis you can do later on. Crowd monitoring. This is one of the recent attracted research area from the last 2 years, and now in the COVID it was more even important, the crowd monitoring analysis. So now again here the crowd monitoring The further it is depending upon application. Just you are analyzing a crowd is not a meaning. So we need to define for what purpose we are going to analyzing a crowd is a challenging question. Now you can able to see here the crowd gathering can be considered in two different ways. One is a normal crowd or another one is an abnormal crowd. Hello? Yes, sir. सर अभी मैं लेक्चर में हूँ सर, अभी मैं 12 बजे बाद और कॉल करता हूँ, ठीक है? थैंक यू सर. So crowd monitoring. So now let's assume the case you are in a mall. There is a musical event is happening inside a mall. So definitely the crowd will going to be gathered there. As the crowd has gathered to watch a particular musical event, it was a normal activity. Now the same crowd is gathering as there might be an accident or there might be a fighting, street fighting, there might be some event is happening which is a normal activity. So now the gathering a crowd will again further defining the whether it is a normal activity or abnormal activity or and so on. So crowd monitoring is also one type of an application where we can able to define for the normal and abnormality, and at the same time we can able to analyze the crowd monitoring for the COVID situations as well. You knew the importance of the COVID situations, right? The crowd and all. So we can able to further analyze the what is the total number of persons and at a particular event, because of the government regulations of 50%. So we can able to analyze the algorithm to count a head count also we can able to analyze here. This is also another applications where the lot of research is happening and it is attracted recently. And the border security, as you already know, that it's always an attractive field and a challenging field as well. And night vision is another challenging field. But if you can analyze all these things, some concepts are common. The ultimate high level processing concepts might be differ, but the basic background concepts are remain same. And later on we are extending our problems to the next level so that the high level process problem can be solved. So what are all that background processing concepts and what are all the challenges here? The first one is we would like to see if whenever you're going to see a problem in a conventional scenes, that means basic CC cameras or street cameras. If you can able to analyze these particular problems to a street cameras, then the challenges are different. And whenever you are trying to take a same problem from a aerial view, then challenges are different. The application is remain same, but the way you would like to solve the problem and the way the hidden challenges are involved during these particular different views are going to play a major role. Let's see some of the challenges here. In the conventional views, the first one is camera jitter problem. Camera jitter problem means, as I told you, that whenever you're trying to go for the in a video processing part, you need to analyze the time series with respect to time, what's happening. Guys, are you able to follow me? Hello?
Yes, sir. Please continue, sir.
Yeah. The first one is a camera jitter problem, another one is a dynamic background problem. Now you can able to see the differences here. Camera jitter is nothing but, suppose your data acquisition device, that is an input camera, is vibrating. It can be vibrated because it is already fixed on a particular street, and it can be vibrated because of the environmental conditions, right? Let's assume it was vibrated, then as because of the input device itself is vibrating or moving, it will going to create an illusion of a motion. How you can able to analyze? Because you can able to, if you can able to analyze the red bounding boxes on the left side image, the left one is at a frame called T, and the second one is at a T+1 frame. Then because of the motion, because of the vibration of the jitter problem of an input device, you can able to feel the differences between the pixels, even though both are belongs to a background. This is very quite common problem. Another interesting problem is dynamic background. Now you can able to see it here. you're trying to take a picture and there is an object which is out other side of the lake, and you are one side of the lake. In between there is a fountain. So whenever you're going to capture a particular video, then the movement of the fountains will going to create a illusion of a motion. The pixels are going to be vary from time to time because the fountain will going to move. Once the fountain will be in a functional, it will going to work. It will going to create a motion. It will going to create an illusion as a motion. But actually it is not a true motion. It was a background information. Fountain will comes under background. So how you can able to make a system to understand that yes, this type of a motion is not considered as a foreground, it belongs to a background motion. So we need to consider these things as a background rather than a foreground. This is another interesting problem. This is another quite common problem, and we should consider these things because which it is a very general problem and which may lead to the wrong misclassification problem or misrecognition problem also, which leads to a false recognitions, right? How we can able to handle this? Let's see. When time goes on, maybe in the evening, you'll try to switch off the lights at the same location. Whenever the lights are going to be off in a particular in a time sequence, the time goes on, you're going to off the number of lights at a particular location, which will going to create a different type of an brightness information at a particular location. Now you can able to see it here at a teeth frame and a t plus 10th frame and t plus 20th frame. You can able to analyze here. In the teeth frame, you have a good brightness but to the 10th frame as compared to the 20th frame. But whenever you're trying to take the difference between the 20th frame with the first frame, definitely you're going to get the pixel differences, even though the background is remain same. Because of the lighting conditions, you're going to see the differences. And this is a very quite common problem. We need to find a solution for this. We need to consider these are the, these are all challenges that belongs to a background only. Second one is a camouflage problem. Camouflage problem means your background and foreground will look similar or will have the same color intensities. So you can able to see the person is wearing a red jacket and the background is also a red jacket. Then how you can able to handle this particular problem? And you can able to see this particular here in the airport. Background is in white color and foreground of the plane is also in white color. So both are looks in a white color. So how you can able to detect the changes of this particular plane at the particular location? So this is also another challenging problem. Camouflage is also a very quite common problem. And weather conditions, especially on the North India, the weather is a major challenging problem. You knew that. So you can able it will be very difficult to see an object in the morning time. So how you can able to handle? So for that there is a concept called haze removal. We will discuss some of the challenges there. And a very quite common problem is a shadow problem. So when time goes on, whenever you are moving, proportionally the shadow also will move. So whenever you're going to analyzing a motion identification problem or a change detection problem, the shadow will also create an illusion of another person, another object, double object. But actually it was a shadow problem. It is not an actual motion, right? So now how you can able to analyze or how you can able to filter such type of problems during the training, so that your deep learning algorithm or machine learning algorithm can easily able to recognize this is a shadow, not a actual foreground. There are many other challenges are there. Night videos is another challenging area, and intermittent object motions, because some of the objects will go very faster and some of the objects will go very slower. So the object motions, the intermittent object motions, also going to create a confusion to the system. Initially they will move very faster, and again they will going to move very slower. So they will go to confuse which one is comes under foreground or which one will comes under F background. So the intermittent object motions also we need to consider to estimate the true motion. So these are all the challenges. So turbulence and bigger moving objects and so on. These are all the different challenges for there on the conventional views. Now, apart from these challenges, there are another problems are there. Whenever we are moving from conventional view to aerial views. Now you can able to see here the applications of the aerial views with the help of the drones. And you knew that the availability of the drones are very cheaper nowadays, right? So if you can able to invest 25,000, you will going to get the drone with a camera. Of course, we have a limitations to use the drones. That was a secondary issue. But the applications of drones are very wide now. Now, on search and rescue operations, the drones can be played a major role, especially on the disaster responses. The drones are going to play a major role, and almost every state is trying to use the drones for various services. Few people are using for the disaster response. Few people are using for the remote monitoring and sensing. Few people are using for the crop monitoring, crop growth monitoring, and many applications are there with the help of drones. So whenever you are going to use a drones, the same algorithm whatever you have applied in the conventional view may not going to solve in this particular aerial view. Why? Let's see this. You can able to see on the different thing. Both are object detection. The left side is also an object detection from a regular view, and right side is also an object detection in an aerial view or object recognition you can consider. So what was the difference between these two, and what was the challenges between these two? So you can able to see on the left side. Guys, are you able to follow me? Is there any questions? Maybe you can discuss. Hello?
Sir, right now, till now, we haven't received any question.
Okay. Okay. So you can able to see the left side view and right side view. You have it both. The applications remains and that is called object recognition. But object recognition is your target, but the input feeding streams are different. First one is a regular view, another one is a aerial view. So in a regular view, you able to see we have very limited number of objects in a frame, and the size of the objects are very bigger. In the left side, you can able to see it here. The size of the objects are very bigger. Let's assume the size of the object which is occupied here, 100 cross 100 for easy reference. But whenever you're going to see on this right side, the size of the object is very small. It is called 5 cross 5 or 7 cross 7 size only. So only 25 pixels are representing the property of an object, what type of an object it is, whether it can be a truck, whether it can be a heavy vehicle, whether it can be a car, and so on. But in the left side, the size of objects are representing, it requires minimum 100 cross 100. That means 10,000 pixels are required to represent or recognize a particular object. This is the first challenging problem. And the second one is, in the regular view, in this particular single frame, we have a limited number of objects. But in the right side, you can able to see, as in the same frame size, you can able to see dense objects. Here you have a more number of objects. And the third one is just you can able to see the visualization of the object properties. Here you can able to feel from your eye, this is a normal cars. But whenever you are going, we can able to see on the right side, it will be very difficult for us to identify which particular part is a car or which one is a truck and so on. Because you are trying to see from the top view, it will be difficult to see. So these are all the other challenges are there from an aerial views. What are the challenges which we have discussed in the previous cases, that is called camouflage and all, shadow problem and occlusion problems and so on. These are very quite, again, a common problems in the aerial view as well. Apart from these challenges, whatever we have discussed in the conventional view, we have these extra challenges for them. So how we can able to solve this problem is another interesting problem. To see some of the challenges, how we have addressed all, you can verify this website as I told you earlier. Verify this website so that you can able to find out the latest the problems and the data sets and so on. So this is what we would like to discuss on this. So from aerial, you can able to see it here. Of course, this is a simple object recognition problem. It's not a moving object recognition problem. Just we have analyzed the problem on the each and every frame, and we have shown on a video. So you can able to see it here. What are the objects are there here? Whether it can be a static, whether it is a moving, we need to recognize. So you can able to see it here. This area, the objects are not moving. It is a parking vehicles. This was the target. So as I told you already, the challenges here is the night conditions is obviously a challenging condition. Another one is the size of the object. That is a moving object. Here you can able to see it here. Whether it is an object, whether it is a on the road, it is difficult to identify. And occlusions here, is an occlusion here. We need to identify those things and see here. the two white cars and two black cars, that these two black cars are creating an illusion of a shadow, and it is like a pit on a road. It's very challenging to recognize. Another one is a dense objects. Instead of recognizing minimum number of objects, we need to recognize more number of objects. That means in a particular frame, you will have the more number of objects. So it was another challenging area. It is a challenging problem. Now, recently, due to the limitations, as I told you, there are some limitations are there. To address some of the limitations, we have, sorry. Address some of the limitations, we have, you can able to see this particular problem here. First one is the video frames. From there, we can able to do this object detection, moving object detection, and moving object recognition. There are the new concepts which recently the researchers had used. One is the object detection. You knew the meaning of object detection. That is called object detection and recognition. So here the thing is, the objects which are available on a frame, where it can be a moving, where it can be a static, it can be recognized. So we have a good object recognition algorithms are there in the literature. That is called YOLO, SSD, and so on. YOLO version 2.5. The second one is standard concept, that is called moving object detection. That is called pixel-wise binary segmentation problem. In this case, you can able to see it here in these particular frames. Only the particular objects which are moving only going to be recognized and detected. Rest of things are not going to be detected. So the static things will be considered as a background. Here you can able to see the persons are there here. Is only going to be detected. But it comes to the second case is moving object recognition. So what is the meaning of a moving object recognition? So here you can able to see it here, moving object recognition problem here. You need to recognize the moving objects with the help of the bounding boxes, not with the help of the pixel-based binary segmentation. So this is the thing we need to identify here. To solve a particular problem, the bounding boxes is a new thing. What was the advantages with respect to the pixel-based binary segmentation? We will see. The second one also you can able to see it here, the object detection, moving object detection, and moving object recognition through bounding boxes. These are all called access aligned bounding boxes. So you can able to observe this particular thing here. You can able to observe here. So whenever this particular car was there, this car, I'm going to start again. You observe here. Whenever you can able to see the car, previously it is having a bounding box. Whenever it has a stop, the bounding box has gone. So here the application is only the moving objects are going to be recognized, because of something which is changing with respect to time to be analyzed with the help of the bounding boxes. Why so it is important? Is it really important? So why? Let's see the problem. In the basically, whenever you're going to develop any of the algorithm for the change detection or a moving object detection, we need the ground truths. Whenever you're going to train any of the model, we need a ground truth for the training procedure. So what are the ground truths we have in the literature? In the literature, we have the ground truth says this pixel-wise binary segmentation problems are there. So wherever the motion is there, this particular foreground information was there in the white color and the background information was there in the black color. So how to generate that? Generating a ground truth of pixel-based binary segmentation itself is a very, very tedious task. It's a very challenging task. If you miss a single pixel or a couple of pixels, if you misclassify, then which leads to the misclassification or misdetection in the accuracy. So how we can able to handle it? So you can able to see how many of the data sets which are available in the literature. Most of the things based on this particular pixel-based binary segmentation problem only. There, the researchers have spent a lot of time to create this such type of ground truth. So creating a ground truth itself is a big challenging task. So you need to analyze the pixel to pixel, you need to analyze the frame to frame, and so on. Let's assume there was an alternative solution was there. Instead of solving a problem through pixel-based segmentation, to save the time, we have any other alternatives of mechanism. Yes, there is another alternative mechanism which is inspired from the object recognition concept. In the object recognition concepts, the concepts have solved with the help of these bounding boxes. So here the bounding boxes, we have a ground has the five values. One is the height and width of the grid and the center pixel of the grid. So based on these 5 values, we can able to estimate wherever the motions are there, only those pixels, only those objects can be created this bounding box ground truths. Then we can able to adopt the concepts of object recognition problems, so that we can able to solve this particular problem through bounding boxes, and it will be very easier. The ground truth generation on these pixelized bounding boxes are easier than the binary segmentation problems. That was an easier task. That is the reason in 2020 you can able to see that some of the research articles are there in 2 A-star conferences. One is one A-star conference, that is the ACMM, another one is WSCV. You can able to find out the solutions on these two. So another interesting problem is anomaly detection. As I told you, it is having very the concept of anomaly detection can be used in many places. It can be applied for the anomaly detection, it can be applied for the violence detection, it can be applied for the abnormal detection and intrusion detection, and many places we can able to apply. How? Let's see. What was the difference? How you can able to define an anomaly? You can able to see it here. We have majorly we have normal events. Most of the time we will have the normal events. So at a particular small interval of time, at a very minute interval of time, you will go on to see some changes. The changes are very high or very low with respect to the normal events. That is called anomaly. Something which is not a normal can be considered as an anomaly. Something which is not at all normal can be considered as an anomaly. So how we can able to see what was the challenges of it? Here the challenges are, as your input data is having more normal data and very little anomalous data, then how we can able to define? So you can able to see it here is in the airport, there is a bag which is on a red color bounding box. You can able to see it here. So there is a bag which is on background. You can able to see it here. This bag actually there from for more than some particular time in an airport. It is not a normal activity. It was an anomalous activity. So leaving a bag in an airport is an abnormal activity. So how we can able to identify the particular object is lie there on for more than particular time period. So this is another problem, and you can able to see it here. So here you can able to see it here. This is a it is a park. In a park, this is the area which is meant for the walking, not for the objects to move or vehicle to move. So people moving in any direction can be considered a normal clip, but inside there is an object which is moving here. It was an abnormal clip. So we need to analyze this particular problem in 2 different manners. First one is we need to define what was the normal activity, and in the testing time, something which is violating the behavior of a normal, you can be detected as an abnormal. And another case of solving is we can able to use simple classification problem and divide the data into 2 parts. What is a normal activity, what is an abnormal activity, and based on this normal and abnormality, we can train the model and we can able to test the model. So in this particular problem also, there are further many number of challenges and the arguments are there in the recent literatures. You can able to see those changes. And this is another interesting problem of AI city challenge in 2019 and 2020. In the CVPR, Computer Vision Pattern Recognition Conference, this in the field of computer vision is the world #1 conference. You can able to see. In this particular conference, this is one workshop which is organized by NVIDIA. So NVIDIA itself has generated one data set that is called AI City Challenge 2019 data set, and it was extended to 2020 as well. If you can able to see, they have generated this data set for the abnormal activities or anomalous activities on the highways. So they have given the proper data divisions of training and validation, and testing they will not reveal, as it is a challenge. So you can able to see it here in the highway portion. Stopping a vehicle is a normal activity as per the rules of highway. So some vehicle is going to be stopped, and then there is a something which is a abnormal activities happening. So what were the challenges were there? Because you can able to see the AI CT challenge is the actual challenge. This is the real data as well. It's not a synthetic data. In this data, if you can able to see the viewing angles, these are all the problems you can able to find out. So these are all the things. Bigger vehicles are moving very slower, and these are all the different. Here you can able to observe the patches here. You can able to detect these patches also as an object. So these are all the challenges are there. Now see, once you have applied some strategy, it's the original video sequence, let's consider. So we need to estimate the background. One solution we have provided. This is the background, how it looks like, and it was an anomaly detected video, something which is any objects are there, it can be detected here through object detector. Then you can able to say it was an anomalous activity. If the background and the foreground are same, then it is a normal activity. So sometimes these anomalous detections we are also going to misclassify. How? Let's see. As I told you, this was a particular original video. You see the object size here. You see the object size here. It's not even looks like an object, but it is a car. And also you can able to see the here. It is a hole or a small partition between this two roads. So this is a pit. Now you can able to see it here. This particular small rectangle shape is also creating an illusion of an object. So once you have extracted the background, as it is not going to move, it is going to be there on the background information. So we have estimated a background. Once I have estimated a background, then we have run the object detector algorithm, tiny object detector algorithm. You can specifically can say. So in the tiny object detectors are detecting these small patches also as an there is a car. So it was a misclassification. So these are all the false positives also be there in the ACT challenge problem. So these are like this. There are n number of problems are there. There are many number of challenges are there while solving a real-time problems. Another interesting and a common problem was facial expression recognition or facial recognition problems. So a person is smiling or not, or the person is a male or female, or what is their age, can able to estimate. And similarly, we can able to estimate what type of an expression, what type of an emotion the person is going to carry. The person can be happy, disgust, contempt, surprise, fear, and so on, angry. These are all the expression you can able to see it here. You can able to clearly observe on the faces here. You can able to observe these faces, fear, anger. You can able to see by seeing a picture itself. You can able to say what type of an expression is having. Now you can able to see it here by seeing her face. You can able to say she is happy. So these are the macro expressions. The expressions which is active on a face for more than few seconds, it will be their macro expressions. And these expressions can be a real or a fake. A person can act as well. And those things cannot be, these are not a true emotions or a true expressions. That was the condition. Second one is you can able to see it here. Can you able to say what about an expression it is? It will be difficult for us to say what type of an expression it is, because here the expression which is not on a single frame, it is on a collection of frames. That means the expression properties are spreaded across the frames. That means the expression is spread on a video sequence rather than a single frame. So this is called micro expression. That means the expressions which are active only upon 1/24th second or 1/30th second of a second only. That means these are the true emotions or true expressions which are active on your face. And it will be very difficult to detect through naked eyes. This is another interesting problem. This is called micro expressions, and very limited researchers are working on this particular problem. Of course, there are some researchers are working expression and discuss expression. So it's very challenging aspect to work on the micro expression than the macro. So what was the limitations of this? Because nowadays everyone is going to talk about the deep learning, right? So what was the first limitations? So as you knew that the deep learning means we are going to use more number of layers, whether in a sequential manner, whether it is in a parallel manner. So how many number of layers we need to adopt? Whether it can be a deeper network, whether it can be a shallow network. What should be the depth of the network? So these are the very common doubts every researchers might be having it. Let's see one simple example. We're going to demonstrate the little challenges here. Let's assume this is a phase. First, you have applied the first layer, that is called recursive convolution. On the response, again, you have applied the second layer. On the resultant response, again, you have applied for the third layer. So if you, whenever you are going to apply these particular three different responses here, input, first response, second and third. Can you observe the third response versus the input features? Whenever you are repeating the same task again and again on a same image, the information is going to be lost rather than the storing. So you can able to see the wrinkles on the forehead and the wrinkles on the chin. At the third level, the things are almost smoothing. Instead of non-uniform information, you are able to see the uniform information. So whenever you're going a deeper, whenever you're running a deeper networks on such type of a problem, instead of holding the features, it may lose the features. And as the network is losing the features, then how it can able to do a proper recognition. So this was another challenging aspect. So we need to take a decision that how many number of layers we need to take, or what type of a structure we need to adopt. This is another challenging problem. This is an interesting problem that is called image captioning. So image captioning, as I told you that in the image captioning, we are going to let's say assume this picture. You can able to see it here. A kid is there, football is there, and there is a greenery background is there. So there are three different things are there on a particular picture. Now your objective is to first you need to detect the what type of objects are there, or what type of information this particular image is having. First you need to analyze that. So here your algorithm object detectors can able to recognize there is a ground, there is a football, there is a kid. So based on these three words, ground, kid, and football, we can able to form a particular caption. We need to generate a sentence. Here the sentence is a kid is playing football. This procedure is called image caption. You can able to analyze here. Here we are going to take the two different strategies. First one is image processing. Another one is natural language processing. So object detector concepts as well as the natural language processing. There is NLP concepts we are going to use it here to solve a particular problem. And you can able to see it here. This is a simple sample example here. You clearly observe, and you tell me is there any mistakes are there or not. See, if you might be seen, if you might be seen this particular video, it was a simple sample video which we have collected in campus, and we have tested on the training model, and these are all the responses we generated. If you can able to see it here, a man standing on top of the sandy beach. A man is correct, and his standing is also correct, but on a sandy beach. Here you have a sand, that is also correct, but it's not on a beach because it is Jaipur, Rajasthan, where we will get the beach. Now you can able to see the another one. You can able to see it here, a man standing on a beach holding an umbrella. If you are able to see this, the algorithm is easily able to recognizing there is an umbrella, there is a person who is standing, but it is able to recognize there is a sand. But again, whenever it is going to see a sand, it is in that it is a beach. So with this, we can able to see this. While during the training procedure, we have taken a publicly available data where the particular persons are standing really on a beach. there the sand is also there. So what type of a data you are going to utilize for this particular training procedure? Based on that only you are going to generating an output, right? So the similar concept can be further extended to the image captioning concepts can be extended for the questioning answer system as well. So what was the procedure? As I told you here, this was an input image. From here, a number of objects can be recognized. From the now, once you have recognized objects, you will going to get the labels. That is called those labels can be used as the words. Here we have detected different words. From the words, with the help of language processing, we can go for the generated sentences, different possible sentences. Then we can go for the re-ranking the sentences, and whatever the top ranking will be there, that can be the captioning. So as per this particular image, the caption is woman holding a camera in a crowd. So here, two different strategies we need to use, as I told you already. The same concepts can be further extended for the visual questioning answering. So visual questioning answering here, you can able to see this is a face with the banana. What is the moisture made of? With the bananas. So we need to provide this particular solution of this particular visual questioning answer systems also with the help of this concept. So what was the procedure? You can see, as I told you, procedure is input image is there. You use the CNN models. From there you get the features of 1024 whatever. From here the word embedding will be there during the training procedure. From the word embedding, you for the LSTM or GRU or anything, any concept. Again, you try to get the 1024 features. You concatenate these visual features and the textual features together and pass it to the fully connected neural networks. That is called that is the last layer, fully connected layer. Then you can able to get the output. So this is how we would like to train the procedure for the visual questioning answer system, or you can able to the changes can be made in this particular procedure to get the image captioning also. Another interesting problem is dehazing problem. So as I told you that dehazing is very quite common nowadays, very interesting problem, and recently IIT Roorkee filed a patent on this, and IIT Roper is also actively working on this particular field. Then you can able to see some of the CVP papers also from IIT Roper recently in 2020. So the image dehazing problem. Image dehazing problem means you can able to see this. This is a dense haze. So you can able. It is very difficult for us to see what the actual object was there on a particular frame because of this particular smoke. You can consider whether it can be fog, whether it can be considered and so on. So we need to remove those things. So this is also different challenges are there also there in this image dehazing problem. And these are all the applications: photography and haze-free sense and haze images, and object detection and haze scenes. As I told you that object detection and recognition is an application. The prerequisite is removing the hazes. So we can combine these two problems together to solve a particular problem. Because from a variable you will have the problem of clouds. So first we need to remove the clouds. That's called haze. You need to remove. Then you have to go for the object detection problems and all. And this is the actual challenging problem. So these are all many applications are there. Now thing is we can able to predict as well. And another one is the automatic colorization of the black and white images. So in our olden days you will have the black and white images. Now we can able to color these images as well. So automatically we can able to color the images so that we can able to get the flavor of a color image. And there's a new research you can able to see in the recent times generating a digital image from a film. In the olden days we have just only film. Through film we can able to regenerate a digital image without developing. That is also little attracted the researchers to work on that. And image imprinting is also another application where the concepts of GAN and all are going to play a role. So now, what are the further challenges are there in this particular process of classification and change detection? There are different strategies of most of the researchers have utilized to show their efficacy, because everyone is going to use the deep learning concepts. They're developing a networks and they're showing their efficacy. But which one is robust and which one is more challenging? and what type of the challenges are generally considerable, or to be make it in a practice, or more which particular training strategies are more towards a real time rather than the offline. So we will discuss on that. Any further any questions set so that we can discuss? Any questions?
Yeah, sir, actually, we have received two questions till now.
Yes, please.
So, can I read out the questions?
Yes.
The first question is it possible to get all parameters perfectly in aerial view in order to apply CBIR?
CVIR?
Yeah, it's this question is in Q&A. You can check it there,
Yeah,
sir.
I'm saying that. Is it possible to get all parameters perfectly? Oh, CBIR. Okay. It is possible to get all the parameters perfectly in a aerial views in order to apply CBIR? Yeah, content-based image retrieval. See, is it possible to get all the parameters? That is where the research is going on, because we need to develop an algorithm in such a way that you have to extract the possible features, or you have to extract the robust features. That is where the challenges are there. As I told you, in the object recognition concepts, RCNN, fast RCNN, YOLO versions of 1, 2, and so on, and RetinaNet and SSD. There are different type of popular object recognition concepts over there. If you might be seen analyzing those problems, they are trying to solve the different challenges, because multi-scale problem is a normal problem, because conventional view the size of the objects are very bigger, but from the aerial view the size of the objects are very smaller. Now how you can able to handle these two different problems with a single algorithm? This is how different approaches were there. And if you can able to see the if you can able to analyze the properties of this all object recognition concepts, there from there you will get to know what actually the challenges were there for each understanding. Of course, yes, we can able to do that. And comes to the CBIR, of course we can able to do this, but this particular problem is based image retrieval. So content here is a features. Based on the features we can able to retrieve the information. But the question here is, from a aerial view, what you would like to retrieve? Based on that we need to make the changes. The second one is, what can be the areas of research in aerial image processing? Can we include dark picture processing? Yes, of course. Train our model harder to identify and differentiate between the multiple objects. See, as I said, applications of aerial images. Many applications are there. For example, whatever the campus you are there, you would like to you would like to do the campus surveillance. You can do that. You can able to do the missing object recognition. You can do that. And at a time frame, whatever the objects are simply laying out at a particular location, if you want to do that, you can do that. A person re-identification through aerial view, you can do that. There are n number of applications are there. Just we need to think about it. That's it. Now, can we include a darker picture processing? Train our model. If you would like to do the, what is the meaning of darker picture? The lightning conditions are lower. Is this your meaning? Or in the night view? If it is a night view, then you have to train the model accordingly. So night view is a little challenging, that too from the aerial view. So if we have the training data, of course we can do that. And differentiate between the multiple objects. Yes, we can do that. That's what I'm saying. If we have a data, input data, then we can able to train it up to some extent. If you have completely darker data, which is very difficult to do it, because somehow it has to see, then we can, there will be always a limitation. Whenever you're going to do the enhancement problem, if your input image is completely noisy, nothing is able to see, how you can able to remove the noise? So similarly, in this particular deep learning also, we have some limitations, but of course we can able to solve the problem. That is how many people are working on the aerial use. And you might be already aware, availability of the aerial data sets are very limited as compared to the normal view. So generating a aerial view data set is also an interesting problem. So people are working on that, and you can able to see some of the data sets we also have prepared. You can able to see those things also. Kindly enlightening the points. Which one? Which point we need to highlight? Yeah, it is a night.
Sir,
Yes, in the night
questions have
view.
been answered.
Yeah, okay. So in the night view, as I told you, yes, we can able to solve the problem in the night view also. As I told you, some of the slides I have shown you. In the night view, definitely we can able to solve the problem. But again, I'm saying that night view, the meaning of night view is we need to train a model. So now you can able to see this. Let's assume here you can able to see anything. Very limited portion of the objects you can able to see. But of course, we can able to remove this dense. We can able to remove this particular information also. I'll show you one thing. Yeah, you can able to see it here. So this is scene. We can able to generate this scene by removing the phases. Similarly, for the night view also we can able to do that. But do we have the data? So system should know how a night view will looks like. Based on that, we can do it. But from an aerial view, it will be little challenging. But of course, we can try for it. Any other question?
Sir, till now, no question is there.
Okay. Let's move to the next challenging problems. How the people have solved the problem in the literature. Now, what are the input data is there? This was just a suggestion for you. You can adopt any concept, no problem. Before applying any of the deep learning concepts, the first thing we need to analyze is what type of a data I have and what will be my application. My application should be clear, and what type of data I'm going to use is these two are very much important, because the input data is the only thing which is going to play a major important role in the training procedure, because your model is going to train on the input data only. So how tough data you are going to utilize, and your algorithm might be going to be trained in a challenging manner. So if you can able to show the challenges, then only you can able to learn. And as you knew that, right? So how we can able to do that is the first part. So in the literature, if you can able to see in the classification problem as a change detection problem, first we'll discuss about the classification problem. To show the most of the researchers have to show their network efficacy, they have adopted some of the biased data division strategies. We will see some of the things and which is not encourageable for the real-time application. The first one is person dependent. What was person dependent? Because it's the subjects. Based on the subjects, they're simply dividing in a form of the training data and testing data. They have simply split it into form of in a random manner. Let's assume I have 100 images of a subject 1 and 100 images of subject 2. Simply I have divided into a random manner of 80-20% or 70-30%. So the same phases in there in the training, and the same subjects are there in the testing also. So you can able to see it here in the training. S1, S2, S3, and S4. There are the 4 subjects are there, and in the testing also you can able to see here S5 and S6, S1 and S2. S1 happy and happy face and sad face, and happy S2 face also there. So you can able to see it here. Training also same face is there, and testing also same face is there. So this is called person dependent. That is called random split training and testing. You can able to see it here. These phases are common. S1 phases are there in the training, as well as the S1 phases are there in the testing. So definitely, whenever you're going to test with the S1 phases, the recognition will be always better as compared to the unseen data, right? This is called person dependent. There is another strategy to little improve the challenges, because we have a limited data sets. Within the data sets, what is the best way we can able to do that? The second way was person independent. So the researchers have adopted the concept of leave subject out. One subject we can able to completely leave in the training, and we can able to test with this on the testing. So you can able to see on the training set, we are trying to train a model on subject 2, subject 4, and subject 5, and so on. But you are going to test on subject 1. If you can able to see the visual features, the expressions might be having common, but the visual properties of a person are different here. So this is what we need to do it. So here we can able to go for the n validation sets. For example, if you have 3 subjects, S1, here in this case S1, S2, and S4, there are 3 subjects. So here I need to go for the 3 different type of validation sets. That means first subject S1 I will consider as in the testing and I'll train the model S2 and S4. In the second time, I will keep S1 in the training and I'll take S2 as a testing. Similarly, for the third time, S1 and S2 I will put it in the training and S4 will be in the testing. So whenever you are going to test on, always on unseen subjects, and your network may be little learn, and it will be even more challenging also. But as you have done the n subject n validation sets, so you have to do the n time training, then you have to take the average out of it, so that you're going to get the first independent final accuracy. Same strategy as I told you. This is the third validation set. I'm keeping you can able to see it here. First one S1 I kept in the testing, and second one I kept the S2 as in the testing by keeping S1 and S4 in the training. Third one is S4 I kept in the testing, and S1 and S2 I have taken the third validation set for the training. So once all the things have over, simply I have taken the average. Total accuracy is the average of inference errors of all n validation sets. As I told you, 3 validation sets, so 3 responses divided by 3. Now, instead of keeping this person independent strategy for the leave one out strategy, there is a next challenging aspect, that was cross domain. So I would like to test, I would like to train on a data set 1, but I would like to test with some different data set. So here, the further challenges the researchers have adopted to show their network capability, network learning capability, or how much robust your algorithm towards the real-time applications. That means it can able to solve the real-time problems. So you can able to see this. They have the training was done in ISCD. This is the Indian dataset, and the right side was tested with the CK plus datasets, and vice versa. So whenever you're going to train a model on CK plus, and if you're going to test on the ISCD, then definitely the results will be little different, because the properties of training and testing will be different. This is another interesting learning area. And right now, in recent times, the system adopted the composite datasets. Composite datasets, how many datasets you have? 1, 2, 3, 4. Just combine all the datasets. Then you adopt this person independent, complete strict strategies, so that the datasets will be more and the challenges will be more. Then you can able to train the model. So this is another strategy that people have adopted. Now let's see about how the particular features are going to be changed by adopting different networks. And these are all the basic networks which are there in the literature, and you might be already aware of those things. One is a LXNet. It was a sequential network. You can able to see this in a sequential manner. All the layers are there, and here we are going to use a same filter size. And the third one is a VGG16. You can also see this. You can also see it here. This is also sequential network of 16 layers, and here you can able to see all the filters are having 3x3 only. So sequential. Another one is a residual network, and you might be aware this RESTnet is one of the popular network which is going to preserve the features instead of losing the features by adopting the concept of skip connections. So this is a residual net, and this is the network. This is a Google net, where they have introduced the concept of inception model. So if you can able to see here the inception model here, the multi-scale features they have used here. What is the meaning of multi-scale? Instead of using a uniform filter size of 3x3 or 5x5, here they have used multi-scale, 1x1, 3x3, and 5x5, something like this. And of course, they have used some of the concepts of little parallelization also. Inception model type they have adapted. This is the first paper which is use the inception models. What will going to happen? What are the things are there? If I'm going to analyzing something in a sequential manner, or if I'm going to analyzing something with the help of skip connections, or by adopting the multi-scale features in a parallel networks, inspiration from the inception models, what will going to happen? Let's see. This is a phase where you have applied the 3-classic convolution, again 3-classic convolution in a sequential manner, and this is the resultant response. After third convolution, you got the response, as I already told you, right? Let's use these basic sequential structures with the 16. And if you want to know, if you want to see this practically, you can train the VGG16 in 2 different ways. One is take an application, the data set, train the VG16 from the scratch, you will get the lower results. And you train the VG16 by adopting the transfer learning. That means as the VG16 was very well trained on the imaginary data set, you take those weights. Based on those weights, you can train the model. That's called transfer learning can end up. So accuracy will be little improved. But as this VG16 and all not meant for this particular type of a classification problem, this is for another classification problem. So those deeper networks may fail here. This is one example I'm showing here just for visualization. Here input image, and this was a first convolution operation, second convolution, third convolution operation. You can able to observe the third convolution, the information is almost vanished. If we would like to use the skip connections or AlexNet residual connections here, so you can able to see an input. The first resultant responses I am going to concatenating or adding at the third response. So I got the response. You can able to see it here. The first response, second response, third response. So after the third response, I am adding the first convolution response. I am summing up the first convolution response, so you can able to see the output here. I hope you can able to see the output here. Instead of you can compare the features of this, visual features of this, visual features of this. I hope you can able to see the differences. So skip connections try to preserve the features rather than ignoring the features. So this was the advantage of using the residual network. Now similarly, why we need to go for the sequential? Why if we will go for the parallel, what will going to happen? Now you can able to see it here. Here I have used two different networks in a sequential manner. I generated the output here. If I am going to apply in a parallel manner, see here, you can able to visualize the features here and here. I hope you can able to see the differences between these two. So this is another advantage of parallel structures. Now the question is, why we need to go for the same filter size? This is a very quite common problem. So here, why we have to go for the filter size, uniform filter size of 3x3 and 3x3? Why can't we go for the multi-scale responses? Of course, we can go for it. You can able to see it here on a same phase. You'll apply for the 3x3 and 5x5, and whenever you're going to combining, you can able to see the differences here. You can able to see the differences here. So multi-scale responses on these particular aspects are going to sometimes you're going to improve or holding the or preserving the features depending upon your application. So you need to apply these strategies from, it will going to vary from application to application. What about the challenges in the change detection? As I told you, the data are going to play a very significant role. And as I told you, this is a pixel-wise segmentation one problem. So in the change detection, this is a fundamental task. This is how we need to go for it. Left side is an image and right side is we need to detect the change moving objects, which we can able to see on the right side. So how it can be solved with the help of this binary segmentation problem, as I explained in the earlier. How we can able to solve this? We can able to solve this problem with the help of these two steps. One is a background estimation, another one is saliency estimation, and then pixel-based segmentation. A thresholding concept you can use, and many other algorithms are there. So your concept is, first of all, you have to go for the background estimation. So there are different there are different algorithms are there, the traditional as well as the deep learning. First, we need to estimate the background. Then we need to calculate the detection from the each and every frame, whether the frame is having a foreground or not. So this is how we will going to do this. These are three steps which are going to play a very important role: background estimation, motion saliency map, and foreground segmentation. These are all the publicly available data sets which are there in the literature for the natural and underwater and the thermal, and some of the data sets for the aerial view also, and the details of the aerial view data sets and all you can able to see this lab. What was the challenges? That's okay. Procedure is quite common and is very it is in practice. What was the challenges here? In recent times, especially of course still as of now, in recent times, most of the researchers have shown their efficacy or effectiveness of the network by adopting a different type of a data division strategies. That data division strategies which leads to a good recognition accuracy, but they are the false. They have adopted the wrong data division strategies to show the efficacy for this particular change detection problems. and some of the algorithms are not even work for the real-time purposes. So in 2020, we proposed one particular data division strategy, which is more important and more towards the real time. That is called scene dependent evaluation and scene independent evaluation. So what was the difference between the dependent and independent evaluation? We have proven, and which particular data divisions are important for this application we have shown. And you can able to find out the papers in IEEE transaction image processing and IEEE transaction intelligent transportation systems. You can able to see these two papers. You're going to get the actual details. Now let's see what particular strategies the people have adopted and what should be adopted. Which particular strategy is required and what actually they are adopting. Let's see. So dependent. Now you can able to see it here. C dependent. Whenever you are going to considering any of the category, you will have the mixture of indoor category. You can consider category. You can consider any category. You can able to see it here. This is one indoor frames. We have divided the video into two parts. One is the sofas category and the traffic, snow, and the traffic. Now let's see the testing data here. Even in the testing data, the same categories are there here. Might be the frame numbers might be different, but the background scenarios are again same. So here the scenes are dependent on the training as well as on the testing. So once your model is already new, what the particular background will be looks like, it will be easier for the system to identify whether the changes are happening or not. So this particular data division is called scene dependent data division. But what should be the tough data division will be like this. Now let's see, I have 4 categories here. You have 4 categories, 1, 2, 3, 4. All the 4 categories on the training and only 4 categories on the testing also, right? This is a little biased. But if you can able to see it here we are going to train on the 3 different set of videos here. But you are trying to test on completely different scene. And the background of testing is not at all there in the training. So this is called scene independent data division. As I told you that in the previous traditional approaches of change detection, the people have used the strictly followed this independent data division strategies, because there's no dependency at all. Just you pass a frame and they're going to analyze on each and every frame. They're going to give the response on each and every frame. But in the deep learning problem, then these particular problems came. So in the deep learning, the challenges and the drawbacks, this particular scene independent data division strategies adopted to develop a network for the real time. And to show who are the articles, which are the articles which are publicly acceptable and which is what type of data division strategies they have used. Able to see it here. These are all the deep learning algorithms. This is a traditional approach. Traditional approach is always going to use the scene independent, but in the deep learning, the people have used the scene dependent strategies. The scene dependent, they have adopted different style of dependencies. You can able to see it here. 50% of the training frame, 5% of the random training frames, and 100% of the training frame, and leave one video out, and many things. There are different strategies they have followed, but the condition here is scene is dependent or independent in the testing is going to play a major role. So we have addressed these all the things by new strategy. It's called scene independent evaluation strategy, and we have developed a network for challenges to show the challenges. And these are all the accuracies you can able to see here. Scene dependent versus scene independence. Whenever you are going to apply the scene dependent strategies, accuracies will be more. Definitely, it will be more as compared to the scene independent. You can able to see it here. But in practice, we need to go for the scene independent evaluation because it's a very challenging data set evaluation. So network developing a robust network is again a challenging aspect. As I want to show you that we can design our own layer also. That is called so this is one paper. Here in this paper, we would like to we have generated one particular layer which as per our application. So I'm going to talking about this particular layer here. So this is a ExpressNet XFit blocks. Here one particular block we have proposed because the Customization layer, yes. This was a customization. We can customize our layers as per our applications. It's not necessary that every time you have to follow the simple strategy which are available on the literature. No, not at all. So we can adopt this particular type of different strategies so that it may going to improve the accuracies as per your application. So this type of customization strategies in this applications of expression recognition, we can able to see the better accuracies here. So here you can able to see the multi-scale responses we have adopted. From there we have extracted the mean and maximum. So the more details about this paper you can able to refer here. I'm talking about the advantages only. You can able to see it here in the basic traditional CNN models. Generally the researchers has just used to concatenate all the responses. But when simply you're going to concatenate, you're going to get this type of responses. But whenever you're going to develop a particular customization layer for a particular target, you're going to get this particular features. So you can able to see the differences. Basic concatenation or addition versus the application specific features preservance network. So you can able to see it here. These particular elective layers are going to hold the required features. So this is one type of thing we can able to observe here. And because of this customization layer, you can able to get the better accuracies here. And as I told you, in the CNN models, the number of parameters are going to play a major role. And within 1690, these are all the deeper networks which are going to occupy 138 million parameter, 144 million parameters. And these are all the parameters are little, costly. So we need to develop a network which should be very lightweight in nature. So the first paper which is proposing 4 million parameters. Later on, this was a paper on transaction image processing. It is a IEEE transaction image processing for the micro expression recognition. You can see, you can verify this paper for two different aspects. One is the micro expression, the video content we convert into form of a single frame with the help of dynamic imaging. Then we have proposed one new network. You can able to see it here. In the CNN models, the people have used 32, 64 filters, 128 filters. Why we need to go for this 120 filters in a single shot? Because we knew that some of the filters may not going to learn. Because whenever you're going to adopt all the filters or applying all the filters at a time at a various depths, not guaranteed that every filter will going to learn. So we are also use the same number of filters, but in a different way. So 16, 16, 16, 16. Total 64 filters we have adopted. 64 filters we divided into 4 streams. Each filter is having 16. So here the depth of 16 we have adopted in 4 streams, parallel streams. And in the parallel streams, we have used the fusion concepts also. What was the purpose of this fusion? Let's see here. The first layer and second layer we have concatenated here. I hope you can able to see it here. We have concatenated here. Similarly, we have concatenated here. Well, these two networks concatenated here, concatenated here. Why? Let's see this particular diagram. So this is the first 16 layers and this is the second 16 layers, parallel networks. But as I told you that whenever you're going to use the more number of filters, there might be some filters may not able to learn the features. Similarly, in the second layer, there are some other features which are not learned. But as I have divided this work into the parallel streams, finally I have concatenated. I have added the 2 different responses together. You can able to see it here. All these responses I was able to capture. The information is preserved here. So this was another advantage of using these particular parallel streams rather than the simple sequences, sequential approaches you can able to see in the literature. So more details on this you can able to refer this as I told you. And of course, as I told you that visually it is going to hold the information differently, going to improve the accuracies. So and here the number of parameters are very, very limited. Only 1.4 million parameters we have within 1.4 million parameters we have solved the problem. This is one Korea conference you can able to see here. In this particular paper, we have proposed 2 different concepts here. One is active imaging. So what is the concept in the previous concept of dynamic imaging? We have proposed to highlight the problems with the dynamic imaging. We proposed an active imaging concept for the micro expressions. Then again, we have proposed a new activation function here. So I'll show you those things as we have limited time. So this is a new activation function, refined rectified linear unit. And you can able to see it here in the existing activation function sigmoid tan H RELU, leaky RELU or ELU. These are all having some limitations. To overcome all these limitations, we have proposed one particular concept that is called RRELU, that is called refined rectified linear units. So for the limits of this refined rectified linear units are shown here. For the more details, you can able to refer this particular paper. A new activation function which were going to be which we have tested in various other applications also, rather than the computer vision. We have applied in the security and networking also. And this refined rectified linear units is outperforming than the existing concepts because of these particular limits. The limits which we have provided was going to be more robust than the existing concepts. So you can verify this thing if anybody interested. Any further questions yet? Doubts? Any questions, guys?
No, sir, I don't think there is any question.
Okay. These are the things you can able to see. Showing here the different activation functions we have tested, and the ablation studies we have done with to show the efficacies of each and every network. And the parameters, reducing the parameters is not only the task, and we need to manage the accuracies also. So you can able to see here with the 90,000 0.9 million, so we can able to solve the problem, but it will going to reduce the accuracies. So the more details you can able to see it from here. And nowadays people have the question that how we can able to visualize something which is inside the network. Yes, we can able to see the responses in the network with the help of these heat maps. So you can able to take the heat map. Heat map can be done with the mean and median and so on. So you can able to go for the mean and median with the help of these various color combinations. These are the color combinations which are there in the any platform you will going to consider. You're going to see these color combinations, and with the help of this color combination, we can able to generate this heat map so that we can able to visualize what's happening inside the layers. Because